In this video, we will briefly discuss constructing a line plot, box plot, mosaic plot, and contour plot, and the method in which they are used. We will begin by demonstrating how a mosaic plot is constructed in JMP. A mosaic plot is constructed with two or more categorical data variables. It is used to visualize data for qualitative elements of a data set. The mosaic plot is generally used to visualize proportions of data overlapping between these categorical data elements. The mosaic plot shows that most passengers were male, however, more females survived than males. In collaboration with the contingency plot, we can see that there were 843 males, 466 females, and 339 females survived, while only 161 males survived. Next, I will demonstrate how a line chart is constructed in JMP. Using a line chart, the series of data is connected by a line. The line shows the changes over time and makes it extremely easy to identify high and low points in the data points. Line charts are very useful when forecasting data in enterprise settings and other industries. Using the Australian tourism data set, you can see that the average length and stay over the years from 1998 to 2011. The highest average length in stay plateaued in the early 2000s from about 2000 to 2001, and the lowest average length in stay was in 2007.
We created a box plot using the iris data table in JMP. A box plot shows the parameters of a single sample of data. It uses the median, upper and lower bounds, and the IQR, which are the 25th percentile, 50th percentile, and 75th percentile. This easily helps to distinguish any outliers in a data set. This is a picture of our box plot with sepal length. The data ranges from 4.3 to 7.9 centimeters, and the majority of the data lies between 5.2 and 6.4. This is the interquartile range. The 50th percentile is 5.8 for sepal length. We created a contour plot using the iris data table. This represents a three-dimensional surface. There are z slices of x and y coordinates where that z value occurs on a three-dimensional surface. We created the contour plot using sepal width by sepal length. The darker areas show more dense areas where the data is more concentrated. This is the contour plot for sepal length by sepal width in centimeters. While comparing the relationship between sepal length and sepal width, we can see that the data is bimodal, as there is one larger dense spot on the top left and one smaller dense spot towards the bottom. The larger spot is around 2.7 with a length of about 5.5 to 7 centimeters, and the smaller is about 3.5 for sepal width and 5 for sepal length.